So here for our week 13 practice, we're going to go over some problems dealing with slope, the slope-intercept form of a line, the point-slope form of a line, and the standard form of a line. As usual, you're going to be given some problems to try, and then after you've tried it on Play Pause It, I will then demonstrate a method of producing the correct answer. So for this first one, you're here to write an equation of the line shown in slope-intercept form. So take a moment, write the equation of this line, and then we'll go through it. So for this line here, and oftentimes if you're given any points that are being highlighted along the line, it is best to use those to be, as accurate. I mean, I can pick other points where it looks like it passes through nice points of the grid, like maybe around here. Maybe even, here, but, those you'd be taking guesses at, whereas these are kind of being highlighted for a reason. And the reason is that, it'd probably be best to use those to come up with the equation that would match, what's, entered into the computer. So, I'm going to start off with identifying what these two sets of coordinates are. So this one appears 2, 6. This one here is -1, 2. And if I had the coordinates of 2 points on the line, I could write the equation of the line pretty easily. So first I determine the slope. So I take the 2 y coordinates and subtract them. And I take the 2 x coordinates and subtract them in the same order. This gives me 4/3, which is the best way to keep the slope. So in slope-intercept form so far, I have y equals 4/3 x plus b. I need to figure out what b is. So I'm going to choose one of these two ordered pairs here. I choose this one here. And I'm going to let this be x. I'm going to let this be y. And I'm going to solve for b. So this becomes a -4/3 over here. I write this as 6/3 because eventually I'm going to be adding 4/3 to both sides to get b alone. When I do that, I do get 10/3. So the equation of this line in slope-intercept form is y equals 4/3 x plus 10/3. And as you can see here, 10/3 is about 3 1/3. You can see it makes sense where it's crossing here, but sometimes students would try to guess, what this is, and put in slope-intercept form. Whereas, it's not really, guessable. I mean, it looks like it's somewhere between 3 and 4, but, do you know it's 1/3 of the way? That can be a little bit more difficult because of the way this is scaled. So, so always use the points that are kind of highlighted so you can calculate what the y-intercept would be if you're unsure, especially if you're unsure of what what actually is. Try this line here. Again, I'm going to use the 2 coordinates they gave me, 0, 4, and 5, -2. So I'm going to calculate the slope. So I'm going to take my 2 y coordinates and subtract them. I'm going to take the 2 x coordinates and subtract them in the same order. And so I get y equals 6 over a -5, which is a -6/5. Now what's nice about this particular problem is that 0, 4 is a y-intercept. Anytime I have an x coordinate of 0, it's going to be a y-intercept, which means that this value here is b. So I now know the slope. I now know what b is. So when I write it in slope-intercept form, it would be y equals -6/5 x plus 4. Try this next one. Now for this one here, if you recognize it's a horizontal line and know how the equation of a horizontal line should be written, you could probably save a couple of steps here along the way. I'm going to show a few more steps that are necessary so that, you can see that even if, you don't recall the equation of what a horizontal line should look like, if you use the same procedure we kind of used on the previous problems, I can still get an answer for this. That's correct. So I'm going to note that these are -5, 6 and 2, 6 as far as the coordinates go. And so when I calculate the slope, my y coordinates being subtracted on top, my x's coordinates being subtracted on the bottom, I get 0 over -7, which is just 0. So if I Start putting this in slope-intercept form. I'm going to have y equals 0x plus b. Now, what goes on with this, it doesn't matter which one of these 2 points are going to happen, because if I put negative 5 in for x or 2 in for x, it's still going to become 0. And so basically I'm going to have the y-coordinate, which both of them have the same y-coordinate, 6, equaling b. So y equaling b is how this is going to look. In this case, y equals 6 would be the answer to this particular problem. And that's the way that all horizontal lines look. It's always y equals the y-coordinate that all the points would share. Here you're asked to write this equation that's described in slope-intercept form. So you're given the equation, the line has a slope of negative 3 and contains the point 0.05. So take a moment, write the equation of this, and then we'll go through it. This was pretty straightforward because this particular problem is giving you what the slope is, so you already know what m is. You don't have to calculate it or anything. And it contains the point 0.05. Now again, 0.5 is a y-intercept because it has an x-coordinate of 0. Y-intercepts always have, coordinates of the format 0, comma b. Since this is 0, comma 5, I know that b equals 5. So with those two pieces of information, it's pretty straightforward to write the equation in the slope-intercept form. And that's going to be y equals 3x plus 5. The next one's a little bit more challenging. So for this one here, I'm not given the slope. And neither one of these are a y-intercept. I don't see any x-coordinates of 0 in these two. So there's a couple ways of handling this. But no matter which way I choose to handle this, is I do want to write the equation in slope-intercept form, I am going to need to know what the slope is. So I'm going to calculate the slope. So I take the two y coordinates and subtract them on top. I take the two x coordinates and subtract them on the bottom in the same order as I took these. And I get 8 over negative 6, which is a negative 4/3 slope. Now there's multiple ways I could figure out what b is to get my slope-intercept form. One way is to use the format y equals mx plus b and choose one of these points. It doesn't matter which point I'm going to choose, and I'm going to demonstrate that. In this first one, I'm going to choose negative 4, 6. So I let y equals 6 when x equals negative 4. Negative 4/3 times negative 4 is 16/3 plus b. 6 is 18/3. When I subtract both sides by 16/3, I get b equaling 2/3. I'd get the exact same result if I use 2, negative 2. The difference would be I have negative 2 for the y, 2 in for the x. I would get these as a result. When I add 8/3 of both sides, I get b equals 2/3. So if I went this route, I already have my two pieces of information. I would have y equals negative 4/3 x plus 2/3 being my slope-intercept form. Another method I could possibly use for this is, once I have my slope, I can start putting this into point-slope form and then convert from there. So, for instance, if I use this point here and put it in a point-slope form, I would have y minus 6 equals negative 4/3 x plus 4. When I distribute the negative 4/3, I end up with this. And then when I add 6 to both sides, 6 being 18/3 again, this becomes a plus 2/3. So you can see I do end up with the same slope-intercept form down here. Likewise with this. Y plus 2 equals negative 4/3 x minus 2, distributing the negative 4/3, subtracting 2, I end up with the exact same slope-intercept form equation. That's why the slope-intercept form equation is often the one that's most often requested, because a slope-intercept form, there's one equation for any unique line. Whereas if I have it in point-slope form, or even as we have it in standard form, I could have multiple equations in those formats for any given line. So one way of sometimes checking to see if your point-slope form is correct, or if you have more than one of them to verify that they're the same line, you could just convert them to slope-intercept form. And if you get the same slope-intercept form, you know it's the same line. But any one of these methods would have worked to get you the answer for this. You don't have to do all of them. Just make sure you know these are available to you and pick whichever one you're most comfortable using. Try this next one. Now for this one, if you notice something about the two sets of coordinates, you could probably do this a lot more quickly if you recognize that this is a very particular type of line. If you don't notice it, doing the work that has been demonstrated in the past few examples would still get you to the same conclusion. So although I'm about to show more steps than is actually necessary, you can still get to the information you need from this. And if you recognize that you have a shortcut with this, then you could certainly cut your work down a bit. But since we're looking for the equation of a line, I do need to figure out what the slope is. So I'm going to take the two y coordinates and subtract them, take the two x coordinates and subtract them. Notice now that they both have the same x coordinate. So as a result, the bottom number becomes 0, and any fraction where the denominator is 0, it's an undefined value. And if I have an undefined slope, that tells me it's a vertical line. Now, at this point, you know, a vertical line it has all points that have the same x coordinates, and the y coordinate doesn't really matter. So me knowing that these two x coordinates are 3 lets me know that the equation of the line is x equals 3. And that would be the, you know, if it said point slope form, standard form, that's basically the only, you know, this is the only equation for a vertical line that would matter. It's usually x equaling a number, just like a horizontal line would be y equaling a number. Now let's try this next one. It's asking for you to keep it in point slope form. Now this one's pretty straightforward because they tell you what the slope is and they tell you that what point it contains. So knowing that the point slope form is y minus y1 equals m times the quantity x minus x1, where x1 and y1 would be the coordinates of a point that the line passes through. And that's why ultimately we have more than one possible equation in point slope form, is that a line will pass through an infinite number of points, and any one of those points could be used, their coordinates could be used to fill in these values for x1 and y1. So now with the information we have here, we're told that the slope is m, and we're told that, you know, this would be the coordinate of a point it passes through. So -8 would be x1, 7 would be y1. Let's put those values into the formula here. Now notice that, you know, everything in orange is part of the structure of the formula. So when I put in the -3 for m, when I put in the -8 for x1, you know, this minus sign here is still staying. So I end up with y minus 7 equals -3 times x minus a -8. And of course, subtracting a -8 turns it into addition. So the final equation is y minus 7 equals -3 times the quantity x plus 8. And you'll often see that in point slope form, is that whatever sign comes before these two numbers, it's the opposite sign whenever I have the actual coordinates. And that's where sometimes students make errors, is that they will attribute a negative sign here to a negative in here and a positive here to a positive out here, and that's not the way it works. It's actually the exact opposite. So let's try this next one. Now for this one here, you actually have two different answers you can give, because you do have two different coordinates that the line passes through, and either one could be used for the point slope form. Both of them are going to be used though to calculate what the slope is. So I'm going to subtract the two y coordinates as usual, subtract the two x coordinates as usual. I get -4 over -2, which is basically just 2. So I know the slope is 2. So I could take this information and start putting it into point slope form, where so I could either use this set of coordinates here and end up with y minus -2, which equals 2 times the quantity x minus -9. And of course these two, the minus a negative here and minus a negative here, both become addition problems. So y plus 2 equals 2 times the quantity x plus 9 would be one solution. The other way I could have went is I could have chosen this point to do it. And so that would have given me, I would have put the 2 here for y1, the -7 here for x1. course, here again I have a minus and negative, so the equations I would have are y minus 2 equals 2 times x plus 7. Again, I could verify that these are both the same line, because when I convert this one into slope-intercept form by distributing the 2 and then subtracting this 2 from both sides, I get y equals 2x plus 16. When I do the same procedure on this, distributing the 2 and then adding 2 to isolate the y, I get the exact same thing. So these all represent the same line. But since we were only looking for point slope form, either one of these two would have been the correct answer. Now the next 5 are going to have you graph being given the equation. So you're going to be directed through a question into a Desmos, where you'll draw your lines, and then once you're done drawing the lines for the 5 equations that are going to follow, we'll then go through them and show you what the graph should look like. Okay, so this one is pretty straightforward because this is in slope-intercept form. So that means that, I know that this negative 3/2 is the slope. This is the y-intercept. And since, for me to use the slope will help me find subsequent points, given that I know a point that the line already passes through. So I need to have a point that the line passes through, and then the slope can actually help me find other points once I figure out what that first one is. So I'm not going to use the slope yet. I'm going to use the fact that this is the y-intercept, which that's the b value. So at 0, 5 is where the y-intercept is going to be, so right here. Now that I have this point that I know the line passes through, now I can use this slope. Now this slope means that I can either move down 3 and right 2, and that's if I'm putting the negative on the top number, or I could say up 3 and down 2, or I put the negative on the bottom number. I mean, so it's one or the other in this situation. Either one would give me the same thing, because if I do them both together, these are the other points I would get that make up the line. So this would be moving up 3 and left 2. This would be moving down 3 and right 2. And I could keep going in those fashions and getting all the points I could get, and that will help me draw the line better. And so the line would look like this when I draw it. For the next one, this one's in point slope form. So again, pretty straightforward because it is point slope. The only tricky part is, again, this plus 3. I mean, the minuses are part of the structure of the problem. So having a minus here tells me that the y-coordinate is 7. Having a plus here, because that means the same thing as x minus a negative 3, tells me that negative 3 would be the x-coordinate of a point that the line passes through. So I know that the slope is 2. I know it passes through negative 3, 7. So again, I'm going to start with this negative 3, 7. I'm going to plot that first. So negative 3, 7 would be right here. And then once I have the first point drawn, I can now use the slope to draw the rest. Now, a slope of 2 can be interpreted as 2 over 1, which means up 2, right 1. I could also interpret it as left 2 and left 1. That would be both of them being negative, but of course we know negatives would cancel anyway. So in either case, these would be other points that I could plot based off of me knowing that the first point's here and what the slope is. And so my line for this one would look a lot like this. This one here is also in slope-intercept or point slope form, so again, pretty straightforward about how to handle it. I know that the slope is 2/5. This means that the x-coordinate for a point that passes through is 10. This indicates it would be a y-coordinate of negative 4. So 10, negative 4 would be the point it passes through. So 10, negative 4, which would be right here, is the first point I'm going to use. If I try to go up 2 and right 5, I can see here I could go up 2, but I kind of run out of space for my right 5. Sometimes that'll happen with certain graphs. So I have to also make sure I keep in mind that if I were to put negatives in front of this, let's go. it's worth the same thing because the negative divided by a negative is still a positive. But this would indicate more of a left or a down 2 and left 5, which I have enough space to make a couple of those happen. So if I go down 2 and left 5, you can see I have all these points down here that I can make use of now. And having those all drawn, I can now draw the line pretty easily. And that's what the line would look like for this one. For this next one, I have this written in standard form. Now in standard form, one of the ways they always recommend that you try to do first is try and define the x and the y intercept. Because if I find 2 points on the line, that's all I need to define that line. So what they would say is, okay, let x be 0 in one instance, let y be 0. If I let x be 0, I would have negative 5y equaling 20. Dividing both sides by negative 5y would be negative 4. So it would be negative 4 here. And if I were to let y equal 0, I would end up with 4x equaling 20. Dividing both sides by 4, I get x equals 5. And so I have two ordered pairs. I have 0, negative 4, and 5, 0. And here's those 2 points, and I would just draw the line through them. That'd be good. Sometimes that intercept method doesn't work all that nicely because there's sometimes issues with it. And here's one here. For this one, I mean, the two issues are, one, that sometimes I don't get integers when I do my x's and when I find my intercepts. And that can sometimes cause an issue. Like for instance here, if I do the same thing I did previously, if I let x be 0, y is 21. Now, in this case here, y being 21 falls way outside of what the range I have showing on this graph. I mean, I only go up to 12 here. So I'd have to go up 9 more units and probably be completely off of this slide here for me to put a point that would be accurate for what would 0, 21 would be. If I do the same thing and let y be 0, I do get x equaling 7. So 7, 0 I could definitely plot. But right now I only have 1 point. So another thing that tends to be done at times is that I can convert this into slope-intercept form, but just by solving this for y. So if I start with this equation here again, subtracting 6x from both sides, I would get, and then dividing both sides by 2, recognizing that since there's 2 terms on this side, both would be divided by 2, I would get y equals negative 3x plus 21. The plus 21 is not a surprise because we know that's the y-intercept at 0, 21. So, but now knowing that the slope is negative 3 will let me figure out how to do the rest of this. Because the slope would be a negative 3 over 1. So it's either down 3 and right 1 or up 3 and left 1. And if I use all of those other points from this starting point here would be plotted along this linear path here, and therefore my line would look like that. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, though, have a good day.